So, good morning, everyone. I welcome you out in this series of lectures related to hydrology. As you all know that we have completed our fourth unit, and the only thing which has been left in your fourth unit is your gumbel method of measurement of flood. This is one of the important question related to flood frequency method because this is asked in your numerical in your university exam. Okay, so we'll study about its theoretical part and we'll try to do some numericals related to that. Okay, so basically this is also a method to determine the frequency of flood. So this is a flood frequency method which is most widely used in hydrological study. So this is most widely used in hydrological study. The general equation for your gumbels method is x t equals to what, x bar plus k into sigma x minus a. Okay, as per the distribution, the probability of occurrence of event equals to or greater than the value of xo is given by. So the probability of occurrence of event is generally given by the value of xo. So the xt value of the flood frequency method for a period of t. Okay, so this is considered for a period of t, and p into what, x greater than and equal to x, so equals to what, this is the equation 1 minus e to the power minus e to the power minus y equals to 1 by t. So you need to remember all these equations because these will be used in your numericals. Okay, here x represent the value of period, that is the flood. XO represent the value of period, X with return period of 0, so it is representing what, X with the return period of 0. Y represent what, dimensionless variable given by what, it is, if Y it is not given, it is given by what, Y equals to what, sigma into X, alpha into X minus your beta. Okay, where alpha is given by what, 1 minus 2825 by sigma x, and beta is given by what, x bar minus 0.45005 sigma x. Okay, this is the value of alpha and sigma, where x bar and sigma x are the mean and the standard deviation of the variate. So here x bar and sigma x what represent, sigma x bar and sigma x represent the mean and the standard deviation. Okay, the dimensionless variable y is rewritten as, so if the dimensionless variable which is y is generally rewritten as what, considering the value of what, as you can see, this is the equation. We will replace what, alpha value will replace x value, will replace beta value. So we have got this alpha value as what, 1.2825, so you are replacing that, okay, by sigma x, x minus x bar plus beta. So this value of beta is what, x minus 0.45005 sigma. So we'll write instead of sigma, instead of your beta, the following value. Okay, now therefore the y, finally the equation for y comes out to be this equation, this, so the value of the equation is coming out to be 1.2825 into x minus x bar by sigma x plus 0.577. okay, this is the equation. Now equation 1 can be transposed and rewritten as, so as you all know that this was the equation number 1. Now we will write what we have got, the variable y, so we'll replace this y by this following term. Okay, now what we are doing over here, where we have got the first equation which is p minus 1 minus e to the power minus e minus 1. So after rewriting it, what we are doing, we are taking this on the left hand side, so this will become positive, and we are taking p on the right hand side, which will become what, minus. Okay, after that, if you are eliminating this minus e, so what we have to do, we have to do the ln of this value, so ln and ln into bracket 1 minus p. Okay, e to the power minus y equals to what, this, we are replacing this minus sign, so we'll give this minus sign to this value. Okay, after that, again if you want to replace this e, again we have to do the value of ln, so ln minus ln 1 minus p. Okay, so finally this is again minus, so replacing this minus, we will be giving this minus to this side. Okay, so final equation for y is this. So for the y, as the reduced variable and dimensionless variable for a return period of t, we have got this formula. Okay, minus ln into minus ln 1 minus, so as I've told you that p can be written as 1 by t, so we'll write t as what, 1 by t. Okay, so ln into what, cross multiply this, t minus 1 by t. So this is the formula for calculating y, t. Okay, After that, now rearranging the equation 2, we get what? Now where is the equation number 2? The equation number 2 is over here. We can rearrange this. So how we are rearranging is this. This is the equation 2. Yt equals to what? 1.2825 into x minus x bar plus 0.7 divided by sigma x. So we are keeping this on the left hand side. So now we are rearranging this equation. Okay, so what we can do, that we can keep this term on the left hand side and all other terms on the right hand side. So what will be the final equation for that? This 1 by 285 will be what, divided by what? This, because this is in multiplication, this will get divided. Okay, yt will be what? Yt this positive will become over there negative, so yt minus 0.5777 into what? Sigma x will be get multiplied. Okay, this will be in division. Okay, so this is the equation for what? After rearranging. Okay, use the formula. So now we will use this rearrange against this, because we knew we want the value of x, so we'll keep x on the right hand side and all the other terms on the left hand side. So this minus x bar will become what? Positive x bar. So x bar plus what? Y minus 0.577 divided by what? 1.2825 into sigma x. So this is the final formula for determination of flood. Okay, this is the final formula for determination of flood, and equation with this, and equate this with what? Equation number A, that is x to the x equals to what? X bar plus k into sigma x. So we can use this also. So we can get the value of k as what? K can be represented by what? Yt minus what? 0.577 divided by what? 1.2825. Okay, so the value of k then become what? Yt minus what? Y bar and divided by Sn. Finally, the equation for what? This value can be written as what? As k. So k will be what? Yt minus y bar n divided by Sn into sigma x. Final equation for flood. This is the final equation for a flood. Okay, now we'll do a numerical related to this. I know this is a bit difficult to understand, but try to understand the equations. Okay, so when we do the numerical, you will get clear all this derivation related to your gumbels method. Okay, you need to remember the equation. Okay, that is the main and important thing. So we'll do the first numerical related to that. So the question is saying that the annual flood data records at a river site gives a mean of 7800 meter cube per second. Okay, the standard deviation of 2850 meter cube per second. Using gumbel method, determine the flood magnitude having a return period of 90 years, taking sigma n equals to what? 1.11 and yn as 0.64. So first we'll write all the given parameters which has been given. So x bar, which is the annual flood, is given as 7800. Here you can see that the annual flood data is recorded at the river side is mean of 7800 meter cube per second. Okay, so it is represented by what? X bar. Sigma n, we have got the value of sigma, that is the standard deviation value. So standard deviation is what? 2850 meter cube per second. Okay, tr is your return period. Tr is given as 90 years, and we need to calculate what? The frequency of flood in the 90 years, that is your x90 we need to calculate. Okay, now using gumbel method, so we have got this formula, xt equals to what? X bar plus kt into sigma. Okay, so for this we need to find out the value of kt. So the kt value is what? Given by what? Kt equals to what? Yt minus y bar n by Sn. Here yn is given as 0.64. So here we have got the value of yn as 0.64. Again, after that, Sn is given as 1.11. Okay, so Sn also is given in your question. This is your sigma n is your nothing but your Sn. So this is what? 0.11. Okay, so the final equation for kt becomes what? Kt equals to what? Yt, we don't know the value of yt, minus y bar n, which is what? 0.64 divided by what? 1.11. Okay, now in order to calculate this yt, we have got the formula. Yt formula was what? This t becomes what? The return period. So the return period is 90. So y90 becomes what? Minus ln into what? Tr divided by what? Tr minus 1. Okay, so this is the value for calculate, this is the equation to calculate what the yt as, or y90. So y90 is coming out to be what, you need to put this values, this equation in your what, in your calculator. You will get the value as 4.4942. okay. Now we have got what, this yt value. So we'll put the yt value in your kt equation. So here we didn't know the value of yt, but now we know the value of yt. Yt is coming out to be 4.4942 minus what, 0.64 divided by 1.1. So kt value is coming out to be 3.47. okay. After that, this kt value can be put in the equation of your xt. okay, because we know the value of x bar, we know the value of now kt, we also know the value of standard deviation. So from here we can calculate the what, xt value. okay, so xt value is coming out to be what, xt value is coming out to be 17689 meter cube per second. okay, this is the value for your xt. okay, in this way you can solve your gumbels method. okay, you can calculate the value of what, flood. okay, xt value you can easily calculate. okay, after that we will see the next equation, your next question. Over here you can see that there is a mean annual flood given, which is your x bar value, which is coming out to be 600 meter cube per second. The standard deviation is also given as sigma is equals to what, 150 meter cube per second. Now what is the probability of flood of magnitude of 1000 meter cube per second? So here we need to calculate the probability. okay, here we are asked to determine the flood magnitude. So this magnitude of the 90-year flood can be of what, 1769689 meter cube per second. That is the value of xt. But here they are asking that what are the probability of occurring of 1000 meter cube per second. That means this much flood will be there, this volume of flood will be there, but it is asking about the probability of happening, okay, in the next 5 years. okay, now what is the probability of flood of magnitude 1000 meter cube per second to occur within the next 5 years? Use the Gumbel method. okay, now we need to calculate the probability. okay, so first we will write all the given parameters. X bar is what, 600 meter cube per second, sigma is what, 150 meter cube per second, xt is given as 1000 meter cube per second. okay, here the probability of flood to be occurred, how many times is not given, n is not given, because obviously this we need to calculate. In this case the probability of flood frequency occurring at least in your 5 years, we have been provided with the risk formula. This we have already done in the previous questions, that 1 minus 1 by t, that will give you the risk value. As t is not known, using Gumbel method, xt equals, we have got this equation for the Gumbel's method, which is xt equals to what, x bar plus kt into sigma. Over here we have got the xt value, which is 1000. This much will be the magnitude of the flood. This is your annual flood. okay, plus kt into what, 150. So from here we can calculate the value of kt. kt is coming out to be 2.667. Again we know that the value of kt is given by what, yt minus y bar n divided by Sn. okay, so here we will put all the value, which is 2.677 equals to what, yt minus y bar n, which is y bar n is nothing but your 0.577, which is given in the question, I think. If it is, I think it is already given in the question, but it is not mentioned over here. So you must add this in your question, that the value of what is y bar n divided by what, Sn. okay, so 0.577, okay, divided by what, 1.285. These values are given, yt, your y bar n value or your s bar n value. So from here you can calculate the value of yt. So yt is coming out to be 3.997. These values are given in your question, but it is not mentioned over here, so I request you to add into your question. okay, now yt can be calculated by what, minus ln into t to the power t minus 1. so okay, so t equals to what, the final value of t is coming out to be what, 54.94 years. So now we can calculate the probability. So the formula for probability is related to your risk, 1 minus 1 by what, t. So the return period is what, 54.9. so probability is coming out to be 0.087. that means the probability of occurrence of this much magnitude of flood is 8.78 year in 5 years. The chances of occurrence is what? 8.78% in 5 years. Okay, so it might ask you the magnitude, or it might ask you the risk or the probability. Okay, these two are the variations in your gumbels method. Okay, we will see one more numerical student. This particular river gauging station, the annual maximum flood are recorded for a period of 60 years. Okay, so we are recording for a period of what? Annual floods are recorded for a period of 60 years. The mean and the standard deviations of the floods are 5400 meter cube per second and 3074 meter cube per second. Using Gumbel's theory, determine the reoccurrence interval of flood of 900 meter cube per second. Secondly, we also need to calculate the magnitude of flood with a reoccurrence interval of 500 years. So in the first part, it is asking to calculate the probability of this much magnitude of flood, and in the second part it is asking that if the return period is of 50 years, what can be the magnitude of the flood. Okay, so in this we have to do in case 1 and case 2 type. Okay, so first we'll consider the case 1. We'll write first the given parameters. So x bar value, which is the annual flood value, is given as 5400 meter cube per second. Standard deviation value sigma is given as 2074 meter cube per second. So the xt value is also given. Xt value is coming out to be what? In the first case, the xt value is given, which is 900 meter cube per second. So from here we can calculate the value of kt. So kt is coming out to be what? You will have to calculate this value as kt. Okay, after getting the value of kt, we'll put this equation, which is yt minus y bar n into Sn. So we have got the y bar n value, which is 0.577. If it is not given, you need to take this value only, Sn, which is 1.2825. okay, so after this you can calculate what yt value. After yt we can calculate what the value of return period t, by using this formula. Yt equals to what? Minus ln into t divided by what? T minus 1. So from here we can get the value of return period of t. Okay, once we have got the return period value, just a minute, let me see what was the okay. After this, once you have got the time period, which is your t value, you can use this probability formula, which is 1 minus 1 by t to the power n. Okay, so after that you can calculate what? From here we can calculate what? The probability, but I think it is not asking probability, is asking the time period, reoccurrence interval. So this is nothing, that t is nothing but your reoccurrence interval. Okay, this is the reoccurrence interval. So now in the second case, the reoccurrence interval is given as 500 years. Okay, we need to calculate what? The magnitude, which is the xt value. So the formula for xt is what? X bar plus kt into sigma. Okay, so x bar is 5400 plus kt we have already calculated, but in this case the reoccurrence period is different, so we need to calculate what? Again this yt value. So yt is what? Minus ln into t to the power t minus 1. This will give you the yt value. From this we can get the kt value. After using this kt value into this formula, that is your first formula, we can get the value of what? X 500, that is the magnitude of the flood in 500 years. Okay, so in this way you can try to solve this methods. Okay, then we will do the last numerical related to your Gumbel method. This one is your last method. Then we are completed with our 4th unit. Okay, over here. So we have got the value of peak flood flow in this question, that is the x bar, that is your annual flood, which is 7820 meter cube per second. The standard deviation is 2500 meter cube per second.
TR, we don't know the value of TR. We need to calculate the reoccurrence period. XTR value we have also been given, which is 1500 meter cube per second. Y bar n is 0.56669. Sn is 1.1938. Okay, so we need to calculate TR value. Now using gumbel method, this is the general formula. Xt equals to what? X bar plus kt into sigma. Okay, so we'll put the value of xt, which is coming out to be 1500. Okay, x bar is 7820. Okay, kt we don't know. Okay, after that sigma is 2500. So from here we can calculate what the value of kt. Okay, kt is coming out to be 2.872. After getting the kt value, we can use the finally get the value of yt from here. So the yt value is coming out to be what? Using this formula, yt is coming out to be 3.985. Now using yt formula, we can get the value of t. Okay, so yt equals to what? 3.985 minus ln into t to the power t minus 1. Okay, from here we can calculate the value of t. So tr is coming out to be what? 54.47 years. So this is the reoccurrence period. After that, this was the equation. The next numerical on gumbels method is what? X250 is given. X50 is given as 2500 meter cube per second. X100 is given as 2900 meter cube per second. X250 we need to calculate. Okay. Now we'll use this gumbel method xt equation, which is xt equals to what? X bar plus k into sigma x. So replacing this k by what? Yt minus y bar n by Sn. Okay. Now x50 is equals to what? 2500. Okay. Yt is given by what? Minus ln into t minus t by t minus 1. Okay. So the reoccurrence period is 50. So we'll write 50 over here, and we'll get the value of y50 as 3.9. Similarly, over here the reoccurrence period is 100 years. So from here we can also calculate the y100 value. Okay. Now x50 and x100 will use the same thing. In this we will use a reoccurrence period of 50, and in the second one we will use the reoccurrence period of 100. Okay, so this is y50 minus y bar n, first one, y50 minus y bar n divided by Sn, and in case of 100 this will be y100 into y bar n into Sn. Now putting the value in this equation number 1 and 2, now we have got the value of what? We have got the value of y50, we have got the value of y100. So we'll put the value over here, 3.9 as your y50 and 4.6 as your y100. Okay, so now by subtracting equation 2 from 1, what we can get? So if you are subtracting this equation, we will get what? 2900 minus 2500, that will give you minus 400. Okay, because this is minus, this will be minus, this will be minus, so this will be minus 400. Okay, x bar and x will get cancelled. Okay, this will be what? This will be what? 4.6, or this will be what? 3.9 minus y bar n minus what? 4.6. Okay, this is already minus, so this will become plus y bar n into sigma x divided by what? Sn. So from here we get what? The value of Sn by sigma x. So Sn by sigma x is given by what? Minus 0.7 divided by minus 400. So the final value of Sn by sigma x is coming out to be 0.00175. This is the third equation. To calculate what? 250. 250 is given what? X250 is given by what? Again the same gumbel equation, x bar plus yt bar yt minus y bar n divided by Sn into sigma x. Okay. After this we'll put what? We don't know the value of yt, so we'll calculate the yt values. Yt 250. So minus ln into 250 minus divided by 250 minus 1. So the value of yt is coming out to be 5.22. Okay. Now we'll put the 5.22 in this value. So x bar 250 x 250 equals to what? X bar plus 5.52 minus y bar n divided by what? Sn into sigma x. This is our fourth equation. Okay, and we will subtract it with our second equation, which is 2900 minus sigma x bar plus 4.6 minus y bar n divided by Sn into sigma x. So subtracting equation number 2 from 4, so the equation will be what? 250 x 250 minus 2900 equals to what? This will get cancelled. 5.52 minus y bar n minus what 4.6 plus y bar n, okay, divided by Sn into sigma x, okay. So this will be what 5.52 minus what 4.6, that will give you 0.92. Okay, this y bar n will get cancelled. Okay, over here we are left with what sigma x by xn. So we can replace this, rewrite this equation as sigma Sn divided by sigma x equals to what 0.92 divided by 250 minus 2900. So we have got the value of Sn by sigma x. So Sn by sigma s was coming out to be 0.00175. So from here we can calculate the value of 250, which is coming out to be 3425.71. Okay, so these are all the variation related to your gumbels method. I think I have clear all the numericals related to your gumbels method. If you have any doubt related to this, please let me know in the comment section, or you can directly WhatsApp me by taking a screenshot. So here we have completed our 4th unit. So in the next class we will start with our 5th unit related to hydrology. Okay, thank you so much.